It needs to be. What class are you in?
Huh?
In Algebra 2.
I don't know how I got here.
I don't know how you did either, to be honest with you. But...
Yeah, thanks. Thanks.
All right, so here's a IXL D1, domain and range. What is domain? It's X values. It's all domain is values of X. And you have to memorize that. If domain is the values of X, what is the range? Values of Y. So most of D1 is like stuff like this easy. What is the range of this function? Ah, okay. You don't need to say 19 twice. And you should probably also list in numerical order. And don't repeat. Now on IXL, they've already got these brackets here for you. So you don't, the example says bracket 1, 2, 3, numerical order. They've already got the brackets there, so you don't have to worry about the brackets. So we're talking about range. Range is Y. And what's our smallest Y value? Negative 16. What's the next Y value? 19. Do you need to say it twice? No, there's no point in saying it twice. And the next value? It's 20. So there's how you answer a question like that. Domain's up next. Well, that's so unclear. Must be my camera. Domain would be what values? All right, let's just define it first. Somebody here doesn't know what it is. What values is it? X. And I didn't have the IXL thing given here, so I'll start with the curly bracket. What's the lowest X value? I agree with that. Followed by A. Followed by A. 14. Followed by A. 18. That is legit as hard as that section gets. Okay? Do I need to do the second example? Looks like an 18 to me. Because that's the highest X value. You have to get that to at least a 90. All right? Because only once you get to 90 does it ask for both at the same time. Okay. So that, yeah, you gotta get your 100. Anybody else 95 or so. All right. Identify functions. So first we're going to define a function. A function is literally a functional relationship. But it's not like a typical functional relationship like relationships that we have. But in algebra, it's considered to be a functional relationship. Now, what does that mean in the world of algebra, that a relationship is functional? It means this, and quite simply, every x has only one y. That's what it's required in the world of algebra for a relationship to be functional. What this means, if you think about relationships that we have, is that x's can't cheat. Y's can. Which seems fitting. Female chromosome's what, XX? Isn't the male chromosome XY? Men can cheat, girls can't. Okay? Now that will not give you a functional relationship in this world. But in the world of algebra, it does. So there it is, kids. X's can't cheat, Y's can. As long as that's true, you're a function. Any issues with the definition? I don't know any easier way to explain it, to be honest with you. All right, So we are supposed to look at this little table and simply decide if it is a function or not. Yeah, there's no repeated x's. That's a good point. There's no repeated x's. You know, -9 is only seeing 10. It's not seeing two different values, it's just seeing 10. Who cares if 11 is also seeing 10? Because isn't 10 allowed to see whatever the heck it wants to see? Okay, so x isn't cheating. And it doesn't matter if y does. So you click the yes button. I think you go through like 10 of those and you're at like a 50. I glanced at it this morning. Then they start doing this to you. Pictures! Why not? Yeah, I'm glad you remember the vertical line test, but can you explain to me in words?
Because there's two x's. If you make a vertical line, it touches the picture twice.
Yeah, see, that's what I'm doing here when I put my dots on there. Like,
Which means x, the same x is used twice, which means it's
that sounds good to me. I made a little point where x was 3 on the circle. When x is 3, it literally sees two y values, doesn't it? So it's cheating. And April and Sean were mentioning what's called the vertical line test. I called you April. I'm sorry, Christina. It won't be the last. It won't be the last, I promise you.
Probably will be.
You have an older sibling, it happens. So they were mentioning the vertical line test. Vertical line test is a pretty simple test. If a vertical line intersects a graph only once, the graph represents a function. You can rewrite that however you want. Big deal is vertical line has to hit it one time. Can't hit it twice, just once. Because of what I was trying to show you there, that x being 3, 2 y values, you draw the line, does the same thing. Does anybody else besides Christina and Sean remember doing a vertical line test? It's something that's talked about like for like 2.5 minutes because it's so easy. And then you do a couple of problems and then you forget about it the next day. That works. So here is like the, I don't know, 55 to 80 something range on IXL. Although this one's kind of got something interesting going on it. Look at the second diagram. There's something different on that thing. Dots. It is an open dot. It is literally what we call a hole in a graph. There is nothing there. There is nothing there. It is what we call a hole in a graph. There is nothing there. So the line passes through nothing. That's right. Well, closed dots are solid points. I guess we'll make a note there since Sean asked. Does this thing even have? This one doesn't have. We'll worry about closed dots when we get closed dots. Okay. Oh, okay. We have a closed dot, don't we? That's a solid dot. I'm just going to say it exists. something there, okay? Now, if you were listening to Christina, which you probably should, she said even if a line passes through that hole in the graph, it's passing through nothing. Okay? So a line cannot touch nothing, kids. So we start drawing our vertical lines here. I'm just going to start with this one. Function or not? Not a function. Line hit twice. Function or not? No, not a function. Line hit twice. How many times it's supposed to hit? Once. How about that guy? Not a function. Same exact text goes right there. This is the one it actually is. And you know what you do is you draw a bunch of vertical lines. That piece is functional, right? You know, this little piece right there is functional. And these holes in the graph, they're functional because you passed through nothing, okay? You pass through a hole. So you can pass through a hole. Well, can't pass through a hole, but you can pass through a hole. They just don't count. So this is the function. Huh? What do you mean why we're cheating? We're not. That's a rational expression. If x was 3, what would you be dividing by? Can that happen? You didn't cheat. There's nothing there. If I was to look at the graph, there would be nothing there because when x is 3, you're attempting to divide by what? The hole in the graph. Not cheating, just math. Why don't you guys take a shot at this one? Lots of those have holes in them. Just take a shot and shut up for a minute and let somebody else try. Just draw a bunch of vertical lines, kids. You can pass through a hole. Ain't nothing wrong with passing through a hole. They don't count. Sean, what you look? Oh, are you using a calculator to plug in numbers, Sean? You said you were smart. All right. Which ones did you guys eliminate? Bottom two, yeah, because these are solid dots. You're hitting twice, aren't you? So these two are just not going to happen. Now, anywhere on the first one, even right through there, you're good to go. You pass through a hole in a solid dot, that hits once. And I see no problem with the top two, do you? So top two are functions. That was a select all. Be looking for that when you do IXL, select all. More than one choice. Need to take D2 to at least a 90 because that's the only way you'll see these graphs with holes in them. And that is kind of an algebra 2 deal that you understand what a hole in the graph is. You need to take this one to at least a 90. Take to an 80, you won't see holes in graphs. Honors kids, you guys need to take that sucker to 100. Yeah, but you won't have a problem. All right, this is D3, evaluate functions, and it has this funky function notation that's going to funk with your little heads, and you're going to funkin' hate it, okay? said funking. I didn't say F-U-C.
We got you. Just wait. We got you.
Okay. Now we could have a big old long lesson about this, or we can just write a little quick note about what this is telling us to do. Replace X, or replace the variable with this number, okay? This is just saying replace the variable, which I think in the first question is X, with a negative 10. That's all it's saying. And I would prefer you do these by hand, but some of you will not be able to do that. It's just the way it is. I'm actually going to work all these out just so I can refresh you on some things. I don't want to bore you. It just needs to be done. So I replaced my X with a negative 10, just like it says. Don't make this harder than it is. Literally put that thing right there. So you've got a negative 4 minus 5 times a negative 10. What are you going to do first? Negative 5 times negative 10, right? Which is 50. So this is negative 4 plus 50. A lot of you guys are going to use calculators, and you're going to wonder why you're just never letting math click. You'll never click with it where you just use calculator. Never will. Anyways, negative 4 and 50 makes 46. Any questions? F of 2. Alex, where am I going to put that 2? Anna, where am I going to put that 2? In the X. We're just going to take it and throw it right there. And I know there's several of you that don't need to write this down. I understand that 100%. I understand it. I wouldn't. Not on that question anyways. Are we going to square or are we going to do the math for the subtraction? PEMDAS, right? Handle parentheses before you handle exponents. Did I hear 9? Who said 9?
Hey, one second. I wrote them as pluses on accident.
It's 5.
5.
Now 5 squared, contrary to popular belief, is 25. There will be a couple of juniors who thinks that means 5 times 2. That's my response to that as well. 5 squared is 5 times 5, kids. You write it twice through multiplication. That's all you do. 5 times 5 being 25. Oh yeah, that's where you put the answer. I guess that's all that matters, right? Where do we put that answer? We put it in that box. All right, use the following to find f of 100. In your notes, I don't know what happened with the copying, but that's a square root symbol, okay? It's a square root symbol. So negative 4 minus 3 roots of 100. That's the substitution step. Christina is very bored, and she already blurted out the square root of 100 is 10. I saw a kid the other day while you were taking the quiz type in 9 minus 3 enter T84. I swear to God I saw it.
So what?
She typed in 9 minus 3. The funny part is she hit the negative key instead of subtraction key, so the calculator said syntax error.
She's a junior?
Yeah.
Yeah, well, I asked you how to figure it. Hey, sometimes you got tricked with it. I don't be trusting myself.
Anyways, what's that root of 100?
I swear.
Grant, you alive?
No, we didn't.
Son, you should probably stay awake for this because you don't want to be the kid who doesn't get this. And you might be. I put questions like this on a test and half of my students miss them. I don't understand it. I don't. So anyways, looks like we got negative 4 minus 30. What do we got? Negative 34. Simple enough. And Trey, you'd put that answer right there in that box. Now this one's on here just to remind you something about absolute value. That's all it is. You see, you got your absolute value bars. The absolute value of a number is always positive because, as Ty says, it's distance. All right? So the first thing we're going to do is we're going to plug in that -7 in for x, and it's about absolute value. So we're going to pull it out absolute value by making it what? Positive. So we have 3 plus 3 more 7s is what we have. 24. Seems like this was one of those that was in like the 55 to 70 range. We're going to skip the next one. We're going to get down to these. These will start showing up in the 80s. Okay? They'll start showing up in the 80s. Use the following function rule to find f of -2w. Simplify your answer. You know, the first thing I wrote here, over here, was replace the variable with the -10. That was the first thing about your notes here. Because we can. On this example, what are we going to replace s with? And that's all there is to it. Replace s with a -2w. We'll worry about that in a second, son. I had more than one kid make a 0 on that quiz, so we'll just go over step by step, okay? Sorry if you know what you're doing on your board. I used to take naps. That's what I did in math class. Take a nap. If you have an A on your board, take a nap. I ain't going to get on to you. If you have a 60 and you take a nap, I will. Now, anyways, what is 3 times -2w? -6w. And it does say simplify, because there's going to be at least one kid who tries to put -6 and -10 together. It's going to happen. Can you? Why not? Not like terms. You can't add 3 apples and 3 oranges. You know that. You just have fruit. You have 6 pieces of fruit. You can't add W's and numbers. No. All right. In this example, what's that R going to become? 10 J's. Everywhere I see an R, it's a 10J. Now, I'm going to write this wrong. That's wrong. Yes. 2 or more wrap. That's 2 things. It's 10 and it's a J, isn't it? 2 or more wrap. If you wrote it like I did originally, it would only square J. It has to square the 10 as well. So we come off to the side and we think 10J times 10J. 100J squared. Notice I only put the 10J where there was an R. Didn't put it anywhere else. Huh? J times J is J squared, Sean. 10J times 10J. Y'all done forgot that, haven't you? Sean has. J times J is J squared. 10 times 10 is 100. Oh, somebody will say 2J. And the last one from this section. Use the following function to find g of 8v plus 2. Simplify your answer. And it's written in terms of j. we're going to say J is 8V plus 2. And it's really just as simple as plugging an 8V plus 2 right there, isn't it? So we'll put it there. There will be some kid who just thinks they know how to do algebra and they just put a 2 there. You're only squaring the 2. It's literally 2 or more in your wrap. And you need to apply that outside of algebra class as well. You really, really do. Now, how do you do that?
8V times 8V is 64V squared.
And then 2 times 2 is 4.
So you think that's the right answer, huh? There's a meme back there. It says Jesus would foil. What you guys just did is what Satan tells you to do. You follow that meme back there. This is literally Satan's work. That's Satan's work, kids. When you square something, it exists how many times? Twice. You write it twice. And you foil. You know, back in 1992 or whenever I took algebra, we just did this. We drew arrows. We figured out what 8V times 8V is. We'll worry about that in a second. Then we drew another arrow. We figured out what 8V times 2 is. Then we drew another stinking arrow. We figured out 2 times 8V. Then we drew one more arrow. We figured out what 2 times 2 was. I don't care what it is. That's foiling. That's exactly what I did. I did the first terms, the outside terms, the inside terms, and the last. That's foiling, okay? Just draw 4 arrows. That's all you do. Then you figure it out. What's 8V times 8V? 64 V squared. I'm going to actually combine these pieces. That's an 8V times 2, which is, that's a 2 times 8V, which is 2 16ths makes 32V. And then the last is 4 plus 4. And this is JC's work. So you can either do Satan's work, or you can do good old Jesus Christ's work. Jesus Christ would foil. And that's it, actually. I haven't actually assigned the stuff on it, so I'll go there in just a minute. But let's say you need to get that one too, a 95. What? It's a 95.
What?
Still just needs 100.
300 is 100.
I'm not gonna go to 100. It's 5 points. It's gonna take me 13 years to get it anyway. What if you miss one?
I think the Wi-Fi failed again, so